Alright, so just going to work on a couple of sorry, so here we go. Now we're starting off with problem 8242, and our first thing we want to do is identify the null and the alternate hypothesis. So we'll read the problem here. If it was determined that the percentage of A's, the letter A's, in English language in the 1800s was 7%. A random sample of 500, and since we got 500, we might as well put in what our n is. 500. So our n was 500. And from that, we got 52 A's. So let's point out what the status quo was 0.07, and that was in the 1800s, the old. And then let's put in what p hat is. P hat would be out of n. Looks like we have a number of successes of 52, which is right here. 52 A's. So we want to test the hypothesis. So let's go ahead and, let's put in our null. P is equal to 0.07. And our alternate says we want to test that A has changed. So this is a two-tail test. So that means P is not equal to 0.07. So we just need to choose which one we have. And it's got to be this one right here, right? There we go. So next we want to get the Z test statistic. And remember, once again, we're talking about P hat minus P, and we do need the standard deviation. Let's go ahead and get that, or standard error. Remember the formula for that is square root n times P times 1 minus P over n. So we've got the values here, and this would have to be divided by the standard error, right? To find the P. So let's see what remission here. P hat minus P over standard error. Why are we not calculating anything? Okay, I guess it did there. Oh, I got standard error. There we go. Now we've got our Z score, which makes sense because now it does appear, based upon our sample, it has gone up from 0.7. So that does make sense that we would have a Z stat positive and to the right. So let's get that one in there. Be sure to get that in there. .97970606495. So and this one we just want to round it to 2 decimal places, so that would go up to 8. So we should have, that should be correct. There we go. So now we just need to calculate the p-value, not to be confused with the population proportion, right? Not to be confused with the population proportion. But now to do that, we will need our stat crunch and our normal calculator. So stat, calculators, go down to normal. And again, we're going to use the standard normal calculator, where the mean is 0, standard deviation is 1, And we're talking about a p-value between this time. It would be a p-value between. Notice, it's what we're going to just calculate the area in the red. And so we're going to have to use the complement of that to find the p-value. So let's so basically what we're talking about here is negative 2.98 to positive 2.98 as our z-scores. Let's compute it. We have that value. Now let's just take that, go over into Desmos, and find the complement. 1 minus 0.997111752. And there's our p-value. So I guess what are they looking for? To 3 decimal places. To 3 decimal places. So it would be 0.003 to 3 decimal places. There we go. Now let's look at what our level of significance was. Our level of significance was 0.05, and when we look at that, we can tell that 0.003 is less than that. So that would mean that it is in the tails, which not even showing up over here. So it is definitely further enough away from the status quo that we can reject the null. And let's see, so we want to reject. The only thing different here is this is not significantly. This one right here says it is. So there we go. All right. Let's go on to the next question here. Let's read this one carefully. A proponent of a new proposed proposition on a ballot wants to know the population percentage of people who support the bill. Suppose a poll is taken and 585 out of 1,000 randomly selected people. And let's go ahead and grab our Desmos and update what our n is. Our sample size is 1,000. And so far as p hat goes, we had 585 successes, as we can see right there. All right. Should the proponent use a hypothesis test or a confidence interval to answer the question? And explain. If it is a hypothesis test, state the hypothesis and find the test statistic. Yes, it's been a long night. The p-value and the conclusion using 5% significance. If a confidence interval is appropriate, find a 90% confidence interval. Well, for one thing, notice that we weren't given a status quo of any sort, and notice what they want to know. He wants to know the population percentage of people who support the bill. So we can't get, based upon a sample, we can't get exactly the population percentage, but we can estimate. So what we're talking about here is a confidence interval. So it's not A. One is appropriate. A confidence interval would be appropriate. And so should use a confidence interval. He doesn't, yeah, so let's see, the proponent should use, see, because the proponent wants to know the proportion of population who will vote. Let's see what he said. Who support the bill, right? He didn't want to know whether or not it would pass. He wants to know who would support the bill. So it's got to be this one right here. Okay. So now we'll go through these series of scenarios. We're not using the hypothesis test, so it would automatically be that one because it's not appropriate. We don't have a status quo. And then entering a test statistics, well, we would need to know, right? If we were to enter a test statistic, the z-score, we would have to have a p to base it on to get the z-score. So again, the hypothesis test is not appropriate. And then the same deal with the p-value, we would need a z-stat, so that's not appropriate. And then finally, again, the proponent should use a confidence interval. Maybe we can convince the computer that that's what we're going to do. So there we go. Now we got it set up. Now the confidence interval is the most appropriate approach. Construct an approximate 90% confidence interval for the population proportion of voters who favor the proposition. Select a correct choice below if necessary. So we are going to use the confidence interval, and I'm hoping that I have saved. Yes, I have saved this right here. Since we're doing a 90 confidence interval, our z's multiplication factor would be 1.645. So we got that in there. Now let's bring up the problem again. So now we need to calculate the error. Remember, that is z times the standard error. So now we have our margin of error. Now remember, what we're going to do is we're going to use what we have here for p hat. P hat minus the margin of error, and p. Oh, did I use a? Let's see. I keep wanting to use a capital. P hat plus the margin of error. So there we should have our confidence interval. So it should be between 57 and 59% at 90% confidence. So there we go. We need to type in our lower value, which is 0.5717. Rounded to 3 decimal places, it would be 5.2. And the upper would be 0.5982. Rounded to 3 decimal places would be that right there. A little tired, but hopefully okay. What did we? Oh, I did the same thing that I did before. Well, I guess I did that on purpose too. Let's see what I did wrong here. So, oh, it's the standard error again. It's the standard error again. So remember, we've got to use the sample. Yeah, I keep doing this on purpose so everybody can learn from my mistakes. No, I'm not doing it on purpose. But it's a good thing to see that it's definitely a great example to show where you can definitely go wrong. And looks like I've done that twice so far. So again, here we go. Now we should have our proper interval 559 tree. And rounded to 3 decimal places, it would be 559. And the other one is 611, just rounding that over here to 3 decimal places. Hopefully I got it right this time. There we go. So again, that is a big lesson there, and it goes. That's one thing that's transitioning over from what we did in 7 to over here, where we're using the p hat on that. So it might be worth a look back to those problems that we were working on before, and I might do that next here to explore the difference between what we were doing before where we're using p. Alright, so hold on a second, we'll get to that. Alright, so I went back to one of these confidence intervals to just focus on the difference between this one just happens to be 7, 4, 5, 6. Notice again, I think here's the thing, like we're not given the status quo. So that's I was just using the p. So it might be a good idea for us to use p hat when we are taking a sample. But we can establish the population proportion only when we're doing a hypothesis test. So let's go ahead and label it as p hat, because that's actually what it is. Notice what our sample is right here. We poll found 583 out of 1,048. So we change this one up here to 583. And notice this wants the population, the percentage, so again, make sure to multiply it by 100. But whenever you start doing your calculations, make sure you take it back and put it there. So now everything should be solid. And let's see, that looks right. So then we can go down, and then we have the conditions. We've done those several times. Remember to check those, because some of those are not going to hold. Don't just click it will hold. Make sure they are going to hold. So now we're going to do a 95% confidence interval. Let me try to bring up the wonderful page that I've been talking about a lot. It said 95, so what we're looking to do is make this z 1.960, because we're doing a 95 confidence interval. So let's bring the problem back up. Here we are. Now we're going to do the 95 confidence interval. Let's make sure our standard deviation is using the sample, and you don't need the complement. Standard error should be good. Z should be good. So we're talking about p hat minus the error, and then notice these numbers match with what they have right here. So that's all good. So I'm glad I went back. So can the confidence interval be used to conclude that the majority of smokers believe they're discriminated against? And yes, it can, because both upper and lower are greater than 50, so that's why we can conclude that. So looking back, it may not be a bad idea as we're working through this to go ahead and consistently use the p hat, even when we're in chapter 7, so that we understand a difference. The only difference is, right, in a hypothesis we will have a status quo, and we'll assign that as just, remember that was the p naught. I guess we could start doing that as well. We could start doing that as well over there, just to be consistent with the variables they're using. Alright. So next up will be chapter 9. And the mouse went weird and freaky. Here we are. Anyway, next will be a chapter 9 bonus assignment, because there's not a quiz for that, but I think it's good to zero in on a few key aspects of it, so that you can get the idea and apply it to the homework and the quizzes. There's no quizzes for chapter 8, but there is one for 7, right?